Have you ever wondered why planets spin, galaxies swirl, and even the tiniest particles seem to be in constant motion? It's a question that takes us from the edge of the universe right down into the quantum world. The short answer: everything spins because of a fundamental law of physics, the conservation of angular momentum. But stick with me, because the full story is way more fascinating than that. Let's start big. I mean really big. Imagine a vast, giant cloud of gas and dust floating in space billions of years ago. This is the nursery where stars and planets are born. Now, this cloud isn't perfectly still. Tiny, random movements from gravitational pulls of distant objects, or slight differences in density, mean the whole thing has a tiny bit of rotation. It might be incredibly slow, almost unnoticeable at first, but as gravity starts pulling this cloud together, something amazing happens. Just like an ice skater pulling their arms in to spin faster, the cloud begins to spin faster and faster as it collapses. This is the conservation of angular momentum in action. The initial, slow rotation of that massive cloud gets concentrated into a much smaller space, forcing it to speed up dramatically. As this spinning cloud of gas and dust flattens into a disk, most of the material gathers at the center, getting hotter and denser. Eventually, the pressure and temperature become so intense that nuclear fusion ignites, and a star is born. Our own sun was formed this way. And because the original cloud was spinning, the new star is also spinning. In fact, our sun completes a rotation about once every 27 days. But what about the rest of the material in that spinning disk? It didn't all fall into the star. This leftover dust and gas continued to orbit the newborn star, still carrying that original spin. Within this disk, clumps of material started sticking together due to gravity. Little bits of dust became pebbles, pebbles became rocks, and rocks smashed together to form larger and larger bodies, called planetesimals. As these planetesimals collided and merged, they didn't just get bigger. They also inherited and combined their rotational energy. Think of it like two spinning tops bumping into each other. The resulting object will also be spinning, influenced by the impacts. Over millions of years, these collisions built up the planets we see today, each one spinning on its axis because it was formed from a spinning disk of material and built from countless spinning, colliding objects. This explains why all the planets in our solar system orbit the Sun in the same direction and, for the most part, spin in the same direction. There are a couple of oddballs, of course. Venus spins backward, and Uranus is tilted on its side. Scientists believe these exceptions were likely caused by massive, catastrophic collisions with other large bodies late in their formation, which literally knocked them off kilter, so even their strange spins are a result of this violent, dynamic process of formation. This principle doesn't just apply to solar systems. It scales up to entire galaxies. Galaxies also form from massive clouds of gas and dark matter. As these clouds collapse under their own gravity, they too begin to spin faster, flattening into the magnificent spiral shapes we see in images from the Hubble telescope. Our Milky Way is a giant spinning disk, and our entire solar system is just one of many, sweeping around the galactic center once every 230 million years. It's a cosmic dance on a scale that's almost impossible to comprehend. So, we've gone from interstellar clouds to galaxies and planets, but the spin doesn't stop there. Let's zoom in, way down to the subatomic level. At the heart of every atom, you have electrons, protons, and neutrons. And guess what? They all spin too. Now, this isn't spin in the way a planet spins. You can't picture an electron as a tiny little ball rotating on an axis. Quantum spin is a fundamental, intrinsic property of a particle, like its charge or its mass. It's just part of what makes an electron an electron. This intrinsic angular momentum is a core concept in quantum mechanics. And while it's a bit mind-bending, it governs how particles interact and how atoms bond together to form molecules. So, the very fabric of matter is built on this fundamental property of spin. From the quantum weirdness of an electron's spin to the majestic rotation of a planet, to the colossal swirl of a galaxy, the universe is in constant motion. It's all tied back to that one beautiful, elegant principle, the conservation of angular momentum. The universe began with tiny, random motions, and as gravity pulled things together, that motion was never lost. It was conserved, concentrated, and transformed into the spin we see everywhere we look. So the next time you look up at the night sky and see the stars, or even just watch water go down a drain, remember that you're witnessing a universal law in action. The universe isn't static. It's a dynamic, spinning, swirling masterpiece, and the fact that everything spins is a clue to its very origins. It's a reminder that we are part of an immense, interconnected cosmic ballet that has been unfolding for billions of years. Thanks so much for joining me on this journey through space and time. If you found this as fascinating as I do, please hit that like button and consider subscribing for more explorations into the wonders of our universe. Let me know in the comments what other cosmic questions you'd like to explore. See you next time.